Hello, everybody. Hope you're doing well. I'm Drew Wright. Thank you for joining Fugue's Cloud Security Masterclass, where we're all about putting engineers in command of cloud security. If you've attended a previous masterclass session, it's great to have you back. And if this is your first time, welcome. We are thrilled to have you. Today, we're going to be thinking like a hacker once again, this time by digging into two real-world cloud exploits that have recently hit the news, and just so we can see how the attackers pulled those off. Before we begin and turning it over to my colleague Josh Stella, who's going to walk us through those, just a few announcements. First, we do have a growing library of Cloud Security Masterclass sessions available to you on demand. You can go ahead and access those at fugue.co/masterclass. And also make sure you sign up for updates because we're always announcing new sessions. Also, our engineer's handbook on cloud security is available for download. It's full of useful information you can use to keep your cloud environment in compliance and your data safe without any of the needless headaches that typically come along with security and compliance. So grab your PDF at fugue.co/handbook. All right, so chat is now open and it will remain so for the duration of this session. If you have any questions or comments at any time, please do pop those into chat and we'll make sure they get addressed. And with that out of the way, let's get on with it. So, hey, Josh, how are you doing? You might be on mute.
Yeah, I never turn on mute on the screen because I have it on my mic and I got double muted. All right. Thanks, Drew. Thanks, Sivia. Hi, everyone. Thanks for joining us. Great to have you here. We're going to have a lot of fun today, I hope. And I'm going to show you a lot of hands-on console today. We're going to talk about some concepts around how hackers think and operate. Oh, let me get to the agenda slide here. Here we go. So why should we think like a hacker, right? That's important. I was recently interviewed for the DevOps.com guys. Alan Schimmel asked me, what's the best way to understand cloud security? And I said, well, understand what hackers are doing, right? I mean, that kind of sounds straightforward, but a lot of folks aren't really thinking that way. So this masterclass series is not about, it can't be about my teaching you everything I know about security in the cloud. I was at AWS as a principal SA. Drew and I founded Fugue. This is all I've done for almost 10 years. Also, I don't know everything about security in cloud. So who the heck am I to teach a masterclass? What these are about is getting you thinking in a way that is going to give you mastery over the topic over time. So what I'm going to try to impart, what we're going to try to impart, are some ways to mental models and ways of approaching the problems of security in the cloud so that you get your own legs under you and run further with it. And one of the things I love about these is when I hear from somebody afterwards that they've explored some new areas. So please do reach out to me. I do absolutely love this stuff. And I love interacting with all of you. As Drew said, the chat's open. Speaking of which, I should get my chat screen open. I try to keep an eye on it, but Drew and Sivia certainly do. Don't use the Q&A. Just use the chat. And please, if you have questions, ask them whenever. We keep an eye on it, and we try to keep up with it. These are much better if they are interactive than if it's just me talking in a vacuum. All right. Can you raise your hand if you've been to a Fugue masterclass before? There's a little raised hand. Okay, Steve. Yeah, we got a few. All right, we got quite a few new folks. So thanks, you can put your hands down. The reason I asked that is we do some fun stuff at these and we have a way we do it. And so for the newbies, which is almost everyone, we know at Fugue, we used to go do events, reInvent, I would go speak and so on and so forth. And one of the things we all enjoyed getting together as a community, and one of the things we all enjoyed, I think, is getting swag and having a little fun together. And so we're going to try to bring that into this virtual environment. So over the course of this masterclass, several times, I'm going to change my Zoom background to something from kind of geek culture, which put another way is stuff I like. And hopefully you like too. And the first person who guesses in the chat to everyone, or who knows what my background is from, is going to win a package of swag from us. Now, if you win one during this session, don't guess again, because you can only win once and you'll spoil it for the others. Okay? So I'm going to go ahead and change that background. Let me see if I can get this off of this monitor. Yeah, I can do that. And I'm going to go to a new virtual background. Let's do something from the history of computing to start. And again, the first person who can tell us what this computer is will win some swag. We're going to do history of computing. We're going to do some science fiction and or anime and video games. Okay, here we go. All right, if you can tell us what computer that is. It's not an Apple II, John. No, it is not. Kevin says that's his current computer. Michael says it's an IBM PC. No, this is the first commercially sold computer that had a mouse. There's a hint for you. Chris says Elisa. No, it is not an Apple product. It is not an IBM product. This might be too hard. Okay, Lacey got it. This is a Xerox Alto, which is, if you've ever heard the story about how Steve Jobs and Apple paid $100,000 to walk through Xerox Park and just see what they were doing. He saw the stuff that was kind of the early form of that computer, and that is a lot of the inspiration for the Macintosh, and then of course Windows and other things after that. Lisa.1 Alpha says Chris. Yeah, fair, fair. Big portrait mode monitor because they were all about documents, right? All right, so we're going to do a recap of the first session, and we've got a lot of folks who weren't in the first session of this, so I'm going to spend a little more time on the recap, and then we're going to do a deep dive into two of these high-profile attacks. Now, before I get into these high-profile attacks, I'm going to put a caveat out there. And by the way, we only have like 6 slides. Most of this is going to be showing information in real time and going to the console and going to the terminal. If you're not a terminal user, don't run away. I'm going to explain exactly what's going on. You don't have to be super technical to follow along here. So I'm going to do a fair amount of recap. Now, the hacks I'm going to talk about, I am going to name names because the names have been named. Both of these organizations are extremely competent at cloud security. So this is in no way a criticism of those organizations. The reason I like doing real hacks is that's how we really learn. The speculative stuff, you know, it's usually not as sophisticated as the real world hacks. All right, and the other thing we're going to do today, as we look at these hacks, is kind of look at the problem space that the security folks on the defensive side and the hackers on the offensive side were engaged in. And that's going to be around things like credentials. It's going to be around things like source code management. It's going to be around things like IAM and snapshotting data and moving data around in S3, okay? So there's a whole, one of the interesting things about cloud security to me is the diversity of ways that hackers can actually do their work, all right? So I'm going to, let's see, what have I got here? All right, let's go, before we get into that, as to, you know, why is it critical to start thinking like a hacker? It's because, okay, so almost all real world cloud breaches are due to misconfiguration of cloud resources. They have far less to do with application or operating system vulnerabilities than in the days of the data center. And even when those are part of a hack, they're a means to an end, right? If you're running a container in the cloud, you probably really don't care that much. Well, let me rephrase that. The hacker doesn't care that much about getting into the container. What they care about is going from that to other cloud resources, because these are intrinsically distributed systems. If you haven't thought about it this way, I would encourage you to. The cloud is just a big global computer, and every app you put in the cloud is distributed. And the hackers know that, and what they're going for are those distributed aspects of it. They want to move around in that cloud environment to steal data, typically, but also to do things like cryptojacking, inserting compute on your bill for them to mine bits of Bitcoin, things like that, okay? So misconfigurations are the real problem here. Many of the ones the attackers use are not really considered problems by most of the compliance frameworks that we're all familiar with if we live in cloud security. So a lot of my background, when I was at AWS, I was focused on DoD and the IC. I did a lot of national security stuff. I've kind of bounced back and forth between national security and tech companies for a few decades now. And, the compliance frameworks like NIST or SOC 2, they're really important. They capture a lot. But what the hackers are doing in the cloud is often ahead of those things. And therefore, they're not, a lot of us rely on those standards to recognize vulnerabilities. And so because the hackers are out ahead and those compliance standards aren't really keeping up in real time, it takes a long time, for CIS to update or whatever. The dangerous stuff in your account are probably not seen as vulnerabilities to your security team or your GRC team. That makes them really easy to overlook. It also makes them incredibly common. A final point here, a lot of folks think that if you can kind of pre-check your cloud configurations, and we are big believers in pre-checking cloud configurations. I'll show you later. We have an open source project out there in GitHub called Regula that will check Terraform prior to deployment to see if there are misconfigurations. But you can't catch everything at pre or at deployment time. And the reason for that is twofold. One, a lot of the ways that hackers are exploiting cloud, and I'll show this today, any one piece might be okay. It's where they're in combination that they become dangerous. And that you can only really analyze in the runtime environment, right? So if you pre-check infrastructure as code, you typically in that template don't have a full picture of the environment that infrastructure is going to either be added to or modified within, and therefore won't be able ahead of time to check whether it's safe. So that's one big reason. The second reason is all this stuff is mutable, or the vast majority of it anyway. So even if you deploy it correctly in a maintenance window, or maybe an automated script, or maybe the application itself modifies the infrastructure, that's actually a common and really awesome pattern. You need to be watching it forever to make sure things that were not there at deployment don't appear later. Attack surface and mistakes, misconfigurations don't happen over time. So in cloud, misconfiguration is the big attack surface. You want to check up front. You want to be aware of what hackers are doing, not just the compliance frameworks. You need both. And then you want to constantly check for that. So this is, we believe, why these things are, and these misconfigurations are in almost all the major breaches that you read about in the news. And none of us want to be in the news. Okay. I'm going to do a quick time check. Oh, wow, we're already 18 minutes in. I always think I don't have enough and then I always have too much info. Okay, we're gonna get into it. I've been in slides. I'm gonna get out of slides because who likes slides? Not me. All right, let's talk about the breaches. So I want to give props. Hey Drew, are you seeing my screen as a browser now?
Indeed. Yep.
Okay, cool. So I want to give respect to Imperva's CTO. Imperva is an awesome company. They make a great product. They had a breach, and the reason I'm calling them out as kind of model citizens in a breach is because the CTO went out and explained exactly what happened and exactly what they're doing about it. And I think all of us in this field really appreciate that. Actually, I'm noticing what time it is. I promised some more backgrounds. I'm going to do another background, and then we're going to get into it. So let's see here. Let me choose a virtual background. All right. Let's see. Let's do some anime. Oh, yeah, let's do some anime. All right, you have to tell us what anime this is from. Here, you got to be able to see the whole beastie. All right, so Heel, I hope I didn't mispronounce your name. Immediately got it. This is from Akira, one of the, in my opinion, best animes ever made, even though it's from the 80s. The kind of solar power satellite that blows stuff up, but super cool anime if you haven't seen it. All right, back to the Imperva hack. So right here, how it happened. So our product development team, I'm going to highlight some things here. This is how hackers think, right? Our product development team began the process of adopting cloud technologies. So they were relatively new to cloud technologies and migrated to RDS. All right, so if you're running RDS, understand RDS is a managed database service, okay? And there are things you need to be aware of when you're running RDS, especially when you're starting out. Some key decisions made during the AWS evaluation process taken together allowed information to be exfiltrated from a database snapshot, okay? Not from the database, from a database snapshot. And I'll explain in a minute in more detail what that means. These were, one, we created a database snapshot for testing. All right, let's think about this for a second. In this breach, real customer data was exfiltrated. A database snapshot was created for testing. Amy says, sounds like someone forgot to encrypt their RDS snapshots. Maybe so, but also the attacker might have gotten, and we'll get into this in a second, the API key the attacker used might also have access to the KMS keys for the encrypted snapshot. But there's another error made here that many of us have made. I have made in my career. It's been a while because I worked in national security that I've done this, but what other errors here, if you think about this? Okay, so the hacker got real customer data from a snapshot made for testing. So a testing environment should never have, nobody's calling it out, so I'll call it out. A testing environment should never have production data. Okay, and I know that's a pain. Lack of data obfuscating, from Jonathan. Yeah, I mean, you can encrypt data, but if your application is going to use the data, it has to be able to decrypt it. And if you get to this next section, an internal compute instance that we created was accessible from the outside world. They don't say the whole internet. They just say the outside world. So that could mean a lot of things. And it contained an AWS API key. Now, an AWS API key, and we're going to focus a lot on these because it's really important to understand them. An AWS API key, if it's in use by, for example, they say here, a compute instance. So if that compute instance contains that API key, it needs to be able to decrypt the data in the database, right? For it to be functional. So that API key, it doesn't matter that the database or the snapshot necessarily was encrypted, because that API key probably had access to decrypting that information so that the application could function, okay? The compute instance was compromised. All right, this is what I was saying earlier. Like in the old days of the data center, getting into a server was a big deal, right? The compute instance was compromised. The virtual machine was compromised. But what did the bad guy do? What did the hacker do? The API key was stolen. Remember, cloud's a big distributed system. You don't really care too much about one instance of compute. You're trying to get to the data. And these API keys have massive blast radius if you're not really careful. All right, Amy says, if they have the IAM privs to either grab the keys from KMS or grant themselves more permissions. Exactly, Amy understands this. If you've seen some of our other things where we're doing like AWS IAM assume roles, you know, changing permissions, and I'm going to get a lot more into these keys and credentials because this is so important for folks to understand. You can do all kinds of kind of really, really ugly stuff. And then, of course, the API key was used to access the snapshot. Now, this is interesting because if you're used to the data center, the idea of snapshots in the cloud way of thinking about snapshots is not something you worry too much about. Usually it's like backup, right? You have some backup solution running. So you know, you're backing up the database off to somewhere else and somebody would have to break into the backup system. But we have found over and again, the ability to do things like snapshot elastic block store volumes or disks, cloud disks, snapshot databases. This becomes a dangerous attack surface. They tend to accumulate over time and people forget about them. And bad guys love to go for them. Why? Because you're not monitoring them usually. So here the hacker didn't attack the actual live running RDS database. They attacked the snapshot. All right, let's talk a little bit about API keys. Now, well, actually, let me go to the AWS console first. And, you know, when I was prepping this, I was thinking, well, I do some presentations where I'm like hacking away at the terminal and stealing data and stuff. And I started out doing this one that way. But I thought to myself, you know, really, as I work through it, I think it's more important to understand the topology that the hacker is attacking. So let's talk a little bit about these credentials and IAM. All right. So what am I in? Yeah, okay, there we go. So I'm just going to show you my AWS users. All right, that's what I'm showing you here in this console. Users and API keys are closely related. Okay, they're very similar entities. The main difference being that a console user also will have a console password. Okay, but what you're really looking for, if you're a bad guy, let's just go in here and generate some of these to show you what I mean. So I've got this user called demo reader, and these security credentials are what I want. This is what's referred to, you see access keys, API key, synonymous. All right, so I'm going to make one here and show it to you. All right, so I'll just show you my access key and secret key because I'm going to nuke all this at the end of the demo. And of course, I'm not showing you a set of permissions that would allow you to do anything bad to my account, which is just a demo account. So these two strings right here, if you have these, they grant a set of permissions to each of your transactions, each of your actions against the AWS APIs, okay? If you have those two things. Now, what did Imperva CTO say? That the compute instance contained an API key. Don't do that, okay? Don't do that. Do not have these in text on a file system in your compute. I'll show you what that looks like when you do it. And I'll explain to you what a better choice is. Okay, so here I'm actually just on my local box. And I've configured, I can do, AWS commands and things like that, although I'm going to get access denied on that one because I have a pretty restrictive policy here. But I'm using an IAM policy that is connected to those credentials. And if I store this stuff locally, then anyone who gets a copy of my disk, right, and on my laptop, that's kind of not as big a deal. One, because it's a dev account. Two, because I physically control this box. But if it's sitting out there in the cloud for ever, if it's a snapshot of a volume of a disk, this data is in there. All right, so let's look at what the data is, right? So let's just do we can just cat it. So in my home directory, so for those of you who aren't Linux, Unix terminal users, all I'm doing here is listing out the contents of a file that the AWS command line uses that contain credentials. All right, and here you can see I've got an access key and a secret access key. All right, these should never be on disks in your infrastructure. And the reason is it's very common practice to snapshot disk volumes. Okay, so what I can do if I'm a hacker is get in to your account. In this case, the Imperva hack particularly, they found that API key. They somehow got into the compute instance. Maybe it was forgotten about. An internal compute instance was accessible from the outside world. Maybe they forgot about it and it had a CVE. Who knows how the attacker got that toehold, but they didn't care about the instance. They cared about those two strings. All right, because then when they have those two strings, they can go and attack other things. That's why you don't want them on the disk. Okay, I'm going to show you the better way to do this. There are actually a couple better ways to do this. So again, rather than just pretending to be this hacker, I'm going to try to educate you on how to thwart this hacker. All right. Now I've got a box out there in AWS running now, a compute instance that is doing this the right way. All right. I'm just going to SSH over to it. All right. This is actually a box I use. In fact, my voice is cracking because I just taught another class on hacking other stuff. And this box is set up to be hackable. Go for it if you want, because I turn it off and recreate it. But what we are doing right here is if I do a cat of, and hopefully I haven't done something goofy here. This is all live, so I'm probably going to make a mistake. Okay. Okay. Yeah. Here we go. Let's just list the contents of that same directory. Okay. So you notice there is no credentials file up here. Oh, I'm in the shell now. Sorry, I'm secure shelled in. On my local box, there was a file called credentials that I listed out and it had the access key and the secret access key. Well, that's not here. So how is this thing working? Does anyone know? I'm going to take a sip while I see if anyone wants to take a guess or tell me how this EC2 instance is able to interact with the AWS APIs. Ah, Tom. Oh, good to see you, Tom. You are correct, sir. It is grabbing them out of the AWS metadata service. Okay. So what's the metadata service? It is let me, where did I put that window? I'll just show you real quick. So on any given running compute instance in AWS, there is the hypervisor, the hypervisor controlling the virtual machine container, what have you, has on it a metadata service. And this is a special IP address, 169.254.169.254. That's always pointing to the hypervisor, okay? And the hypervisor has a bunch of information about that instance that the instance itself doesn't know. Now, people have kind of maligned this service. Used properly, it's way better than many of the alternatives. I think it's really quite good, actually. And used properly, and I'm going to tell you why shortly. This is a better way to go. It's definitely a better way to go than embedding credentials on a disk anytime. So if I query that, and for the non-terminal folks, curl is just a command that's like pointing your web browser at a URL. Okay, we're just doing it in text instead of a visual clickable thing. So you can see here there's a bunch of information, and I can actually drill into the IAM role that is associated with this compute instance. So I'm just drilling in and curling again, 169.254, 169.254. I'm going into the latest metadata into IAM, which is the permissions, the API key is associated with that IAM role, and the security credentials for that role. Whoop, I got something wrong. It's inevitable that I will make a mistake when doing this, right? Oh, I just got done teaching a class on this and I changed roles. So maintenance role is not the right role. So you can see here S3 read write is the right role now. All right. All right, and I just got, guess what? The access key and the secret access key. So rather than embedding these on the disk, they're coming from the metadata service. And the metadata service, if you look at when this was last updated, it was today. Okay, so you're getting a couple of things. It's a twofer. One, when you snapshot the disk, there's nothing there that matters in terms of credentials. That's good. You should never have credentials on the disk. Two, the credentials, the keys are being rotated. Now, if I go back to my account, which again is kind of set up to be insecure. Okay, here we go. You can see right here, this set of keys, the access key is 199 days old. That is not good. Why is that not good? Because the hacker is counting on time that they can use that. So thinking back to the Imperva breach, right? The compute instance was compromised, the AWS API key was stolen, and then the AWS API key was used to access the snapshot. If they had been using these rotating credentials, unless the hacker got in and immediately within the rotation time got to the actual database snapshots using those credentials, there's a time limit on how long those keys are useful. Now, what are you going to do if you're not using the metadata service? If you're embedding these things in source code, and we're going to talk about that in a second, or putting them on a disk, you're not going to want to rotate them that much because it's a pain. Does anyone enjoy changing passwords? No, it's a pain. But if you're using the AWS, and I'll just show you here briefly what this looks like. What I'm showing you here is our product Fugue, but I'm just showing it to you so you understand how these credentials work with compute instances. So come on now. So this compute instance, this EC2 instance, right, we've got all the metadata about it over here, and you can see it has the IAM instance profile of S3 read write. So it's getting permissions automatically by that association without having to put anything on the disk. Is that making sense? Does anyone have any questions about this so far? Yeah, so Amy says EC2 metadata from the command in any Amazon Linux AMI, if I recall correctly. Amy, that's right. I think that's in response to where the cred's coming from. It's because Amazon Linux instances, if you just spin them up and you associate them with an IAM policy, they're at the operating system level, they're already configured to use the metadata service. Okay. I didn't get any questions. I'm going to do another background here. We're 38 minutes in, so I think we got time for a couple more. All right, what should we do? Let's do a video game. All right, first person to name this video game gets, a t-shirt, and some Civi can tell you exactly what, but a swag pack. Anyone know this one? We have gamers in this session. Andrew got it, and then Chris got it. Sorry, Chris. Andrew got in ahead of you. It's a game called Hollow Knight, and it is a really wonderful game about cute little bugs, and it is terrifying, and I highly recommend it. Yeah, nice job, Andrew. Hollow Knight. Okay. Where were we? Let's talk now about another hack. We just talked about the Imperva hack. We're going to keep talking about the Imperva hack, but I want to talk about another hack that that got reported in the news that we don't have the details. The wonderful thing about the Imperva hack is the CTO and the company were stand-up folks, and then they said, what I should do before I move on is just tell you their corrective actions, because these are the right corrective actions. They did the right thing. They told everyone what happened, and they fixed it. And so you can learn from these. One, applying tighter security access controls. Absolutely, that's what Fugue exists to do. It's hard to do, but you need to do it. Increasing audit of snapshot access. Okay, this is interesting. So a lot of folks don't think too much about snapshot access. In fact, in a hack that happened a couple of years ago, the way the hacker got the credentials is not only were they left on a file system in an EBS volume snapshot, but that snapshot was accidentally dropped into a public S3 bucket. All right, so all a hacker has to do in that case is go and, hey, there's an S3 bucket, I'll list the contents. That's a disk image, I'll grab it, I'll mount it up on my own AC2 instance and go for it. So you need to consider your snapshots, any kind of backup data that lives in the cloud, as attack surface, okay? Decommissioning inactive compute instances. All right, let's go back to my terminal here, because I have intentionally, on this host, ignored it for a long time and let it accumulate a whole bunch of security patches that it needs. So 56 packages needed for security. So this points to another critical issue in cloud security, which is knowing what you're running. Not having orphaned infrastructure out there, because it will accumulate CVEs, it will accumulate vulnerabilities, you won't be paying attention to it, it probably still has the credentials you granted it, right? And that becomes a particularly attractive attack surface. We see it over and over again. So orphaned infrastructure, it's why at Fugue we built this whole visualizer thing. It's weird for a security company to build a visualizer. The reason we did it is because very often when you look at a diagram, you go, hey, what's that network? What's that server doing? What's that container there for? So you need to get rid of that stuff. And I couldn't be more, as somebody who lives and breathes cloud security, I couldn't be more pleased with this corrective action list. Rotating credentials and strengthening our credential management process. Again, time is your enemy. If your credentials last for a long time, in my goofy hackable account, I've got a set of keys that have been for 200 days. That is a disaster waiting to happen. So good call. And again, if you use the metadata service, it's going to auto rotate them for you. You don't even have to muck with it. So it's pretty cool. Yeah, putting all internal compute instances behind our VPN, that's a good idea. And increasing the frequency of infrastructure scanning. These are what you want to do. By the way, Fugue does most of these. This is not a product pitch, but this is the stuff we do for a living. And these are excellent corrective actions. So props to Imperva. In this other breach, which Uber chose not to talk about much, we had a different vector to getting the credentials, okay? So we talked about at length the vector of having them on disk images, snapshots, etc. And I'm going to come back to the stealing data part. I just want to talk about the credentials part again. So in the Uber breach, what we know is the attacker got credentials out of a private GitHub repo. Okay. So let's think that through for a minute. Why would credentials be in any kind of source code repo? Does anyone have a guess? No? Mistakes, Michael says. Yeah, initial commits, yeah. To make CI easier, yes. A legacy system, could be. I'm gonna hard code and source code, yes. These are great answers. So let's talk about, mistakes. So what if I am using Git and I'm on, this machine right here, right? And I'm in like I've got different AWS configs in my different projects rather than just one in my root directory. And I check my, maybe I'm writing a Haskell program or a Go program. And in that project folder, there's an AWS configuration. Okay, so again, let's just do a bang cat. So again, this AWS credentials file, maybe I've embedded that just for, doing dev. And I do my commit, and it happens to be in the path of what I'm committing from Git. That's going to be in GitHub now. That's going to be in my SCM. Okay. So that's what I would call mistakes and initial commit. To make CI easier. So this one I've seen before, and this is where you should really stop yourself and not do it. Right? It's kind of like forgivable and understandable to accidentally grab some creds from your local environment. I mean, you should be watching for it. Your pull request, whoever approves that pull request, needs to be talked to, right? But you don't want to intentionally do this, okay? Because it's a bad idea. What's going to happen? There are implications to intentionally doing this. One is you're almost guaranteeing that those keys need to be long-lived. And you never want long-lived keys. Why would they be long-lived? Because if you're embedding them and using them intentionally as part of a process, updating that process and synchronizing that with AWS, that puts you in the position of doing key rotation. And very few people do that right, to be honest. And again, this is not pejorative. I'm just telling you what I've seen. Very few people do it right. And what tends to happen is the key rotation gets ignored. And therefore, you have two problems. One is you've got keys that you've intentionally embedded in some place people can get access to them. And two, you probably have them long-lived to make that CI system work longer. So there are other ways to do this. Use a secrets manager. HashiCorp has Vault. AWS has one. Use the secrets manager. Don't embed it. But in the case of Uber, it was embedded somewhere in their private GitHub repo. Now, this gets interesting to me because a lot of times we think about, or I think about anyway, cloud breaches as being like cloud service provider, like AWS, Azure, Google, Alibaba, those kinds of scenarios. But GitHub is a software as a service company, right? I mean, I think there's still an enterprise deployment, but it's a software. It is another piece of cloud. Well, how in the world can a bad guy get to a private GitHub repo that's managed properly? What's managed properly? All right, let's I'll get myself over to GitHub and log myself out and log myself in, just to show you what I mean. So if you think for a moment about, oh, look, I'm not signed in. Awesome. If you think for a moment about using a private repo, and we use private repo. This is a public repo. You're welcome to go to it. It's an open source project, super cool. We put it out there called Regula for checking Terraform. But to get to a private repo, I have to be logged into this cloud service. All right, so let's see what happens when I try to sign into GitHub. I'll just use my Okta to do that. Ah, but wait, there's more. Why? Because I'm using multi-factor authentication. So if you think about, and the way that GitHub does this is pretty good. You can use an app or this. If you had this, you could get in here if you had the password. Now, if you think about that Uber hack where an outsider got into a private repo, what that suggests to me is either it wasn't really an outsider, but the news kind of said it was. So they probably didn't have MFA turned on. Is it possible to defeat MFA? Yeah, but now you've got to go hack some other stuff to get another device to be the credentialing device for the MFA. So it makes it a lot harder. And so I'm skeptical. I don't know, but I'm skeptical that they were taking the serious attitude that's needed for those repos. Now you may say, well, I mean, we have Fugue. We don't have anything in our repos. I mean, we have proprietary secrets and so on. You know, we write a really cool application with tons of Lambda. We know a whole lot about what we do. But I guarantee you, in our repos, there are no creds, right? So you don't want that. By the way, there are scanning tools for GitHub to check and see if your repos have AWS creds in them. If there's time, I'll show you one. All right. So there are different ways to get these credentials. However, if you're rotating them regularly, right? Somebody grabs one out of a private GitHub repo, who cares? It's already expired. That also means it's useless in the SCM, and you shouldn't have it there. But it's expired, so who cares? All right. Okay, so I've talked a ton about credentials. I'm going to do one more background, and then I'm going to talk about how to steal data. All right, because we've got a few minutes left. Let's do a background. And while I'm picking out a background, throw anything in chat you want me to talk about, or any questions, or if you just have a general question about hacking cloud, do what you like, ask what you like. Oh, let's do some more science fiction. Okay, now this one, a lot of people are gonna get right away, but you have to name. Let's do this one instead, actually. This is a fun one. All right, this is going way back in the day. All right, I'm doing a science fiction TV show background. Name that TV show. Oh, John Hunt got it. Lost in Space. You know, if you were a kid in the 70s like I was, you looked forward to this thing. All right. Yeah. Congrats, John. So I must have people as gray-bearded as I am in here. All right. Or if your dad rented the entire thing when Netflix rented DVDs, you've got a good dad, John. Excellent job, John's father. All right. Eero asks, and I'm sorry, I'm sure I mangled the pronunciation there, where to best learn these AWS security practices. Boy, the stuff I'm showing you, I mean, I don't know if I can tell you, like, other than here, that there's a single source for these things. I mean, the way I approach this is I read the news, and then I go and attempt to recreate things or understand what really happened. And that's kind of what I was getting to about the compliance families being behind, right? It's these API keys being stored in snapshots or in SCM, et cetera. There's all kinds of stuff you can do with those. So I don't know that there's a one-stop shop. There's a ton of great docs on AWS security best practices. The AWS security certification is very thorough and covers a lot of what I'm talking about. Maybe not everything, but a lot of it. Okay. So yeah, we got enough time here to talk about how we're going to steal data. All right, I'm going to share a different screen and just whiteboard real briefly. I've got a new setup here, so hopefully, are you seeing a white whiteboard?
We are.
Okay, cool. So, okay, when you're stealing data, there's a couple few ways to go about it. So let's talk for a minute as if, oh, come on, wake up, Photoshop. There you go. There's a DynamoDB database. So now DynamoDB databases are interesting because you don't need the internal database credentials to use them. You just need IAM privileges. So if I've gone in and gotten, creds off an EC2, or I'm borrowing the IAM role that it's running under, and I can talk to DynamoDB, one simple way to suck the data, I don't need a database password, right? DynamoDB respects the AWS IAM permissions, is just to, pull the data out. Now, if I'm hacking, I'm not going to do that because you're probably watching that, right? You're probably paying attention. If somebody sucks all the data out of your DynamoDB tables, hopefully you'll notice that and stop it, or you're using a service or a product that helps you stop that. So I'm going to take a different approach. I'm going to look for snapshots of that DynamoDB table. And chances are, if I have access to the table itself, I will either have the ability to see and read the snapshots, another place where list and read access is extraordinarily dangerous, right? So actually, honestly, I would isolate those two things, but a lot of people don't because they don't know that's dangerous. So I would isolate the ability of this EC2 instance to read and write to this DynamoDB table from its ability to look at snapshots. But I've seen it over and over again that it's there. And in fact, often that same set of permissions on EC2 or on a container or even on a Lambda might have the ability to make a snapshot. Where do those snapshots go? Anyone know? Mm-hmm. Amy's right, S3. All right, so these snapshots are resident in S3, okay? S3 is a great place to steal data from. It's also highly secure if configured correctly. But if I can generate a snapshot from there, I can then move it to another AWS account. Let's see if I can draw a pirate flag here. With another S3 bucket using something called a sync command, throw it over there. I've got that data. Now, if I'm smart while I'm doing this, I'm also, if these are in fact encrypted snapshots with keys, I'm probably grabbing the keys too, right? Now, the same is kind of true with RDS. The difference here is RDS usually requires both the IAM and database login credentials, which should be stored in a secrets manager. Okay. So if this EC2 is talking to RDS, the fact that I might not have any IAM permissions to talk to RDS. There's different ways to do it, but I might need database credentials. So if you're a hacker, needing multiple sets of credentials makes your job much harder. And so in this case, I might just use the API to, again, make a snapshot and shove it over the wall. Now, if those aren't encrypted, you're in real trouble. And if they're encrypted using KMS keys that this thing has access to, or in the case of, if I've stolen creds at a GitHub, all I need are those creds. I don't even need to be inside your AWS account. I could be outside, depending on how you have it configured, and potentially going in, snagging a snapshot, and throwing it back over to somewhere externally. So we're just about out of time, and I want to respect time. As usual, I was worried I didn't have enough, and it's filled up the session, and I still got some here. So, well, let me open it up. Anyone want to cover, dig deeper into any of this stuff? Any questions or things you'd like to learn more about?
I have one, Josh. and it might be kind of a noob question, but you talked about how secret keys can wind up in GitHub repos. How does that information wind up on instances in your environment?
Yeah, so it ends up on instances in your environment if you're not using the metadata service and you're instead embedding keys on disks. So if, I showed you how, well, let me share it again because clearly I wasn't explaining it well enough. I think it's that guy. And this guy. All right. So here on my, this is Mehalon's my local box. I have right in my home directory, right? Tilde, this little funny character, is my home directory in Unix, Linux, Mac OS. In my AWS directory, I have a file called credentials, and in there are my actual access key and secret access key. Okay. If you do this on a container or on an EC2 instance in the cloud, they're sitting there on all those snapshots. Okay. So again, the answer to this is to not do that and instead use IAM roles in the metadata service. So here I can do, an AWS S3 LS. AWS S3, did I type S2? I always type S2. Yeah, okay, there we go. I'm listing my S3 buckets here. That means I have credentials, but if I do a cat of the same thing, right? Actually, here I got to list it because there's not even a credentials file. There's just a config file. There's no credentials. So the credentials are being picked up from the metadata service. Therefore, on this thing, this is the right way to do it. They'll never show up in a snapshot. They'll never show up on disk. You can also use secrets managers other than, just using the metadata service. There's different ways. The important point is never have them embedded in source code, never have them on the disk file. All right. Let's do one more background just to round it out at the end. I like giving away swag. Thivia, I'm sorry. All right, one more sci-fi TV. Somebody's going to get this right away. I believe in you. All right, but what is this? Yeah, Chris said it's Doctor Who, yes, and it is the TARDIS, yes. That's the old school TARDIS, not the modern Doctor Who whizzy bangy TARDIS. All right, I think we're going to wrap it up now. Drew, I'm going to turn it back over to you.
All right. If anybody has any additional questions or comments for Josh, you can reach out to us. I know Josh is at josh@fugue.co. We are at hello@fugue.co if you'd like to learn more about Fugue or do a one-on-one session with us to kind of take a look at your cloud security challenges. And again, check out the other master classes at fugue.co/masterclass. And we've got some more coming up over the next couple of months, and look forward to seeing you. So thanks again, everybody, for joining us today. This was fun.
Yep. Thanks all. Take care.